Okay, we have already heard quite a lot of tau hierarchy observations in the previous talks. And so I start with some feedback to the observers and then go through a short list, only briefly touching the different showers, and perhaps more important about ongoing projects, what's still open. Because I found out when I prepared this talk that I just completed 50 years of own visual observations. And so I have seen almost everything you can imagine. Feedback to the observers. What does it mean? Right now, we have in this year more than 930 sessions in the VMDB, and these cover more than 7,600 hours. And as you know, usually observers submit data in blocks of, say, 2 hours, 3 hours. And so that means all these session reports, which are incoming, are checked for inconsistencies, so that we have a look into the data, whether there is some obvious thing which is not correct. And this is done by a small group, Rainer, who has been the visual director before, Bob, Ina, and myself. And that also implies that the comments which are possible to be given at the end of each report are indeed read. Some of us, or at least one of us, finds out if you give some additional remark in the comments and it's not lost just as a decoration or something which is not of importance. So this is also something which can have additional value. There's some open things. For example, the shower list, that's not a fixed one. That's the same as with the IAU Meteor database thing, where we have to update it regularly. And those of you who regularly report sessions will find out that there are showers popping up in the pop-up menu, which are not really active in the given year. So that's why, yeah, for example, in December, it will happen that the December FICAS repeats will pop up when the Andromedates are actually active. That's because the database is to some extent fixed, and so the shower association must be done very carefully. For this update of the shower working list, we have a small working group. It's more or less informal. It includes Tim Cooper from South Africa, Masahiro Koseki from Japan, Bob Zirko covering then the video data, myself and Chris for the radio data, so that we have at least comments concerning all branches. As I already mentioned, we have a brief list, and not to stay here at this point too long, I will go through the individual shower data which we have. So there's one interesting thing with the quadrantides. Essentially, it was observed very well. You see here in this graph, that's the ZHR graph, which is from the EMO page, directly from the VMDB generated. And that's covering the peak period on the 3rd to the 4th of January from 19 UT to 4 UT in the morning. And you see the rate is just in the order of between 60 and 70, which is surprisingly low. And we have a decrease of activity towards the morning. And for comparison, to have an independent data sample, that's the flux from video data, which Zirko introduced this morning. And so we see also this decrease towards the morning. It's also between, here it's 18 UT till 4 UT. It's basically the same UT range. And yeah, the rate is, or the flux is also quite low. And because the quadrantide activity seems to vary from one return to the next considerably. I already started a long-term study, and there's one comment of Jeremy, he repeated a few times, modeling this stream is really difficult. But if you look here, that's from the book of Peter Janiskins, where this figure is included. That's the 2022 return here, this passage through the stream. And you see that's one of the thinner returns. And now, with the data we have, we can go back for about 20, 25 years and check whether this has some similarity with the model. And perhaps we find also something else, because the quadrantids are strongly affected by Jupiter's gravitation, and so we will have a look into this in the coming weeks. Then something really unspectacular, especially as compared with the Tau Hercules story, which comes a bit later. We had a very normal return of the April lyrics. The long-term average ZHR, which we know from visual observations over decades, is about 18. And that's the reference solar longitude. This one is the reference solar longitude. What we found in this year is that the maximum was obviously a bit later, about 3 hours. And the rate was just of the order of 15, and also the data between the video flux again and the visual are quite similar. I always try to have the same time span here on the abscissa. So that's why the figure here sometimes looks a bit squeezed, but to make it the same scale was the easiest way to do that. Then something which for many observers is more or less out of range, because the observing windows are short. That's the Eta Aquarius. And you see that's the distribution of the observers. Of course, those here in Central and Middle Europe and so on, they cannot contribute that much. So we have to rely more or less on those close to the equator or even south of that. And then we have a quite good coverage for this year. And the interesting thing is we find in ZHR well above 30 for about 3 days, 3 consecutive days with some scatter, but there was no prediction of any activity exceeding the normal level. And I find 3 days in a row, that's quite broad. We can also check what happens with the video data. And we also see that's from 4th of May till 8th. There's no data point for the 9th. And it's also of this level. Interestingly, the ZHR level derived backwards from the flux resembles very much what we see also in the visual range. That's not often the case. Silke often pointed out that the determination of the ZHR, the back calculation, is not very reliable, but you see here, and also we will see it soon in another moment. It's really not too bad. That brings me to the Tau Hercules, again, the visual observations. Again, we have heard that many people traveled to North America. We also had a whole bunch of observers in Europe. And I myself and a few others were to the Canary Islands, which were essentially out of the window for the main peak, but they were well placed for all activities which happens earlier than that. And we will hear about this by Pavel a few talks later, I think. And that's what we saw in the data. It has just been published in WGN, so I don't go into the details here. Interestingly, the population index is around 2.5, 2.4 in this early period, which goes here from 22 UT till shortly after midnight on that day, the 30th of May, and then the value continues in this range. And the ZHR, the main peak, you have also seen from the publication, it's given here, it's 55 plus minus 7, centered at 505 UT. And this early maximum, which is obviously composed of meteoroids released at a different occasion, not the 95 breakup of the comet. That's a ZHR of 18 plus minus 3. And the population is slightly higher. But that's interesting to study this maximum as well. But there we need also the data from other sources. That brings me to one thing which in the first moment you would think it's not worth to look in detail. That's the moonlit Perseid. It was just one day after full moon this year. And the first poor appearing information is that the ZHR just reached a level of 60. That's really remarkably small. And that resembled something which we found in the early 2000s when I made this analysis with Peter Brown concerning the Perseid peaks from 93 to 2000 approximately. And we always found that the ZHRs obtained during moonlit conditions were too low. That's also something Zoko mentioned in his talk this morning. And that seems to recur here as well. There's something happening with the perception if the background is bright. Also here, I have the comparison with the video results, and you see immediately the ZHR derived from that is about twice the level which we have here from the visual data. So despite these conversion problems, but as we have seen before, the difference is not that much. And so at least we have to search for a correction which is about a factor of 2. And how should that work? First, there's one additional source or additional data sample which we can have a look at. That's the radio forward scatter data published by Hirofumi Sugimoto from Japan. And here you see this radio ZHR, and the black dots are the visual ones, like this from here, transferred here. It's not the same reference date, so that differs a bit, but you see it's about 60 for the visual data. And he also finds out that the ZHR must have been of the order slightly above 100 at the same time. Also, the difference here, the further you go away from the full moon, the difference is much, much smaller, or it's even close to 0. And with the waning moon, yeah, there's no data point mentioned here, but you see the effect is largest close to the full moon. And we have already done a lot of special observations to attack this problem. And one of the things I just recently did, under perfectly clear conditions, I observed and took data with the sky quality meter. That's the scale here on the abscissa. That's my personal limiting magnitude. And you see that with twilight, when it gets darker, so it moves like this, from low values of the sky quality meter to darker sky, and darker. And if then the moon rises, then it goes the other way around. The ascent is much steeper than the descent before. So there's a significant difference in the effect of backscattered light from twilight, where the source of brightness is under the horizon, and we have a segment in the sky which is bright, and the moonlight, where the object which causes the disturbance is in the sky, blocked by some obstacle, of course. Normally you do something like this, and but it's different in the effect, as it seems to have not only one segment in the sky which is brighter, but the entire sky. Something which is still open. We will have similar diagrams for hazy skies and for city lights.
Jürgen,
That
I don't know
already
if you
brings
can hear
me.
us. The last one. Yeah, the time is over, but we have time for the last slide.
Exactly. These numbers I don't need to report. One thing which I want to encourage you, continue with the visual observations, because then we have the chance to look into the long-term evolution of showers. For example, we did it already for Geminids and Orionids over about 100 years, for Eta Aquarids, Taurids, about 50 years. So there's a lot of things to be done. And just a final thing, if you are sitting outside, that's time for you. And like the meteors cross your field of view, it's also that new ideas cross your mind. So take this advantage to observe. Thank you.